A graph of the band of stability is a chart that graphs the number of protons on the x-axis versus the number of neutrons. You can see up to about 20 protons that it is stable if there are 20 neutrons also. Right after the 20 and 20, you can see it veers off. This is the stability area. It is more stable to have more neutrons for the number of protons. You should be able to read a table of band of stability and answer these questions here. So you should be able to determine what type of decay occurs and be able to write an equation. So putting it all together, I have cobalt 75. The number of protons is 27, it tells me. And then to find the number of neutrons, I need to subtract. So 75 minus 27, and I get 48. So I'm going to read on the graph that point. So 27 protons, so right about there, and my number of neutrons is 48, right about here. So I end up with a point right about there. So this is outside the band of stability, and this would be beta decay. If you're told beta decay without telling you if it's minus or plus, then assume it's always minus. So this is a beta minus decay. Let's do the next one. So the next one, uranium-238, I have 92 protons, and so subtracting, I get 146. And for this one, the 146 is a little bit not needed because once you get past 83 protons, you are in the alpha decay area. So 92 protons and 146 would be way up here, kind of off the chart, but this would be alpha decay. And our last example here, I have calcium 30 with 20 protons, and when I subtract, I have 10 neutrons. So I'm going to find the 20 and the 10, so I'm right here. This is just below the band of stability, and so I'm going to have positron emission or beta plus or electron capture. We can sketch out some equations. So with cobalt 75, here's the beginning of the equation. I just need to put what's left over. So you'll need to look on the periodic table what 28 protons is, and I get nickel. Let's do the next one. So I need to put what the leftover is. There's the alpha particle. So 234 and 90, and then look up on the periodic table. That would be thorium. And the last one, there's the equation for if it's a beta plus emission, and we can do the equation if it's electron capture. There's the equation if it's electron capture. So here we have an electron is pulled in, and here we have a positron is emitted.